In 1977, a fragile machine no bigger than a compact car was launched into the cosmos with nothing more than 8-track tapes, a nuclear battery, and a golden record. Voyager 1. Its mission was simple: explore the gas giants, send back photographs, and then vanish into the cold embrace of interstellar space. But what this probe just discovered 46 years later is not part of any plan. It's not something we expected. And according to some inside NASA, it may not even be something we understand. Because out there at the boundary where our sun's influence ends and the great unknown begins, Voyager 1 encountered something that shouldn't exist. A massive wall of heat, a rising pressure, a low-frequency hum that refuses to stop, and clues that the structure of the universe might be far stranger than we believed. This isn't just the end of a mission. It may be the beginning of a cosmic revelation. Voyager 1 wasn't supposed to make history. It wasn't designed to last more than 5 years. Its primary objective was simply to visit Jupiter and Saturn, gather photos and readings, and drift off silently into the dark. But gravity had other plans. Using rare planetary alignments, Voyager 1 accelerated beyond expectations, past Saturn, past the Kuiper Belt, and into the very fringes of the Sun's magnetic reach. As the decades passed, its power source, a radioisotope thermoelectric generator, kept it alive, turning radioactive decay into electricity. One by one, non-essential systems were shut off to conserve energy. Its cameras went dark after the famous pale blue dot photo. Its instruments were reduced to just a few, measuring magnetic fields and charged particles. But Voyager 1 kept transmitting, moving farther from Earth than anything before or since. It crossed the heliopause in 2012, becoming the first object to enter interstellar space. And that's when the true mystery began. What it started detecting on the other side of the solar bubble was more than radiation or wind. It was something deeper, something more structured, something alive with pattern. Shortly after crossing into interstellar space, Voyager 1 picked up a signal, not from Earth, not from the Sun. A low, steady, persistent hum hovering around 3 Hz. Scientists at first thought it was background plasma noise, a kind of leftover static from solar radiation. But this hum didn't fade. It didn't fluctuate like natural turbulence. It was stable, constant. It pulsed with rhythm, and it didn't behave like anything they'd heard before. As months became years, the signal remained, and it began to tell a story. Its frequency shifted over time, correlating with bursts from distant solar activity. But what puzzled scientists most was how localized it felt. Voyager wasn't picking up this frequency everywhere. It was centered in a very specific region, just beyond the heliopause. The hum seemed focused, as if the void itself was whispering from one particular direction. NASA began mapping it, cross-referencing it, and slowly a pattern emerged. This wasn't random noise. It was structured plasma, a form of vibration that may carry information about the true layout of space. Voyager 1, without even trying, was hearing the heartbeat of the universe. And no one expected it to sound like this. Then came the second shock. As Voyager drifted deeper into the unknown, its instruments recorded something astonishing. Heat. A lot of heat. Not from a star, not from an explosion, but from a wall, an invisible barrier of plasma where the pressure and temperature spiked dramatically. Scientists had long assumed the heliopause, the boundary between the Sun's solar wind and the interstellar medium, was relatively calm. But Voyager 1 found the opposite. At the edge of the heliosphere, it encountered what researchers are now calling a wall of fire. Temperatures in this region have been estimated to reach between 30,000 and 50,000 degrees Celsius. That's higher than the surface of the Sun, and no one can fully explain why it's happening. The Sun's influence should be minimal at that distance. And yet, something is causing this boundary zone to boil with activity. Some believe it may be due to the compression of particles where solar and interstellar winds collide. Others suspect an unknown source of energy or even undiscovered forces at play between galaxies. The fact that Voyager survived its passage through this zone is another mystery. With such high temperatures, one would expect significant damage. But thanks to the low particle density, the probe may have simply slipped through, undisturbed, but deeply altered. The deeper Voyager 1 moves into interstellar space, the stranger the readings become. Pressure in the medium was expected to be low, but instead it's higher than any model predicted. Cosmic rays behave differently than expected. Particle densities fluctuate without explanation. It's as if Voyager is not floating through a vacuum, but through an active shifting sea. One of the most puzzling discoveries came when researchers analyzed a solar flare from 2012. They expected both Voyager probes to respond similarly, but they didn't. Despite being in similar regions of space, the two Voyagers measured radically different cosmic ray intensities. That means the heliopause itself may not be a simple line. It may be a constantly morphing boundary shaped by invisible flows of force, temperature, and radiation. And more recently, Voyager's data has revealed the possibility of interstellar plasma behaving like fluid, flowing, pulsing, and reacting as if part of a larger system. Some researchers have gone further, suggesting that space is not the calm void we believed, but a highly dynamic network of energy, and that Voyager may first be floating through one of its critical nodes. The deeper it goes, the more it sees. And the more it sees, the more it challenges every theory we once thought was certain. One of the most confounding discoveries from Voyager 1's recent data isn't just what it's detecting, but where. When Voyager 2 crossed the heliopause in 2018, it did so at a significantly different distance from the Sun than Voyager 1 had in 2012. This shocked scientists. The boundary of the heliosphere, the very edge of our solar system, was supposed to be consistent or at least predictable. Instead, it behaves like something alive, breathing, contracting, and expanding with solar activity. It's not just the location that varies, but the character of the boundary. Voyager 1's passage was abrupt. It went from detecting solar particles to cosmic ones almost instantly. Voyager 2's experience was more gradual, and the difference in readings suggested something startling. The heliopause may not be a smooth boundary, but a wrinkled, fluctuating membrane separating us from the true interstellar medium. This membrane responds to solar cycles, galactic conditions, and possibly even gravitational forces we don't yet understand. Voyager 1's continuous data shows that the shape of the Sun's influence is not spherical as we long believed, but oval, warped, and stretched by external cosmic winds. This changes everything. The solar system isn't a static bubble. It's a shifting, twisting field reacting to galactic turbulence. Voyager is no longer just a spacecraft drifting in the void. It's navigating through a dynamic frontier where the rules themselves are evolving. Another enigma that has emerged from Voyager 1's long journey is the measurement of pressure in deep space. The interstellar medium, the space between stars, was assumed to be cold, thin, and inert, but Voyager's instruments suggest otherwise. In multiple readings, the pressure exerted on the spacecraft from the surrounding environment is significantly higher than predicted. Where is this pressure coming from? Initial theories pointed to cosmic rays, high-energy particles streaming through the galaxy. But the density and flow detected by Voyager doesn't match the expected values. What's more, the directionality of these particles shows subtle changes over time, as if being nudged or redirected by something unseen. This implies the presence of forces or fields that standard models can't account for. The most puzzling part, this added pressure appears to be uneven, pulsing at irregular intervals, as though Voyager were moving through pockets of denser energy or unseen waves. Some theorists suggest these may be remnants of past supernovae or massive shock waves traveling silently through the void. Others believe we're witnessing interactions between dark matter fields and plasma, phenomena so rare that they can only be detected once every few thousand years. And Voyager 1, by sheer luck, is right in the middle of it. As Voyager 1 continues its voyage into unknown territory, another question lingers, a human one. What happens if someone or something finds it? Affixed to the body of the spacecraft is one of the most ambitious acts in human history. The Golden Record, a copper disc carrying music, sounds of Earth, greetings in dozens of languages, scientific data, and even the location of our planet. It's a time capsule meant to represent humanity in case Voyager is ever intercepted. At the time, this was seen as a poetic gesture, an invitation to the stars. But today, some scientists are no longer so certain. Because if Voyager 1 is now crossing unknown fields of energy, brushing up against structures we can't see, and recording harmonics that resemble organized resonance, then maybe it's not alone. Maybe something is out there. And if it is, the Golden Record becomes more than a symbol. It becomes a message with a return address. Should we have included so much information? Were we too eager to be discovered? The spacecraft that was meant to represent peace might one day become the reason we are noticed in ways we can't control. Despite all these discoveries, Voyager 1's clock is ticking. Its power source, plutonium-238, is fading. What began at over 400 watts has now fallen below 200. One by one, instruments have been shut down. The cameras are long gone. The recorders are offline. Only a handful of detectors remain, scraping what little energy they can to continue their silent vigil in the stars. Yet, even now, NASA's engineers are fighting the odds. They've rewritten ancient code, redirected power, altered the timing of thruster firings to compensate for propellant decay. All in the hope of keeping Voyager alive until at least 2030. Every year beyond that is a miracle. Why are they trying so hard? Because Voyager 1 isn't just a machine. It's a witness. A messenger from a forgotten century still alive at the edge of time. It continues to report on the nature of space, even as it becomes part of a space we don't yet understand. And until its final signal fades, it may still reveal something impossible. Something no telescope, no satellite, no human eye could ever see. Voyager 1 was built in a different world long before smartphones, GPS, or even the Internet as we know it. It was launched not with expectations of immortality, but with the hope of glimpsing the unknown. And yet, 46 years later, this aging spacecraft is still whispering from the edge of forever. Still discovering, still surprising, and still teaching us that the universe is anything but empty. It wasn't supposed to hear anything, but it heard. It wasn't supposed to survive a wall of fire, but it did. And it certainly wasn't supposed to detect a humming, pulsing, shifting structure of plasma and pressure that defies the textbooks. But it has. The truth is, we're only just beginning to grasp what Voyager 1 has found. A heliopause that breathes, a temperature that should incinerate, a hum that echoes like a voice, and a universe that might not be silent, but subtle, full of patterns, rhythms, and questions we haven't yet learned to ask. This impossible discovery isn't just about deep space. It's about how far we can go with determination, curiosity, and a little piece of metal powered by fading plutonium and human dreams. Voyager 1 is not just drifting in the dark. It's illuminating it. If this left you awestruck, if you believe Voyager 1's latest discovery is far more than science fiction, then don't miss what's coming next. Subscribe, hit the bell, and join us on this journey into the unknown. And tell us in the comments, do you think Voyager 1 has just scratched the surface or uncovered something we were never meant to find?